Hey everyone, one of the fundamental building blocks of any programming language are functions. In Solidity, for any actions that you perform, you will need to call a function inside your contract. In this video, we are getting into the specifics of how functions work in Solidity. Let's get into the video. The syntax for writing a function in Solidity is the function keyword followed by the function name, then the parameters, then the scope, then function type, and finally returns. Function keyword is used to indicate that the following is a function. The function name is used to uniquely identify the function. Then we have the brackets inside which you have comma separated parameters for the function. Next we have scope. There are 4 types of scope keywords which affect the visibility of your function. These are public, private, external, and internal. Next, we have function type, which basically defines how your function affects the state of your contract. Regular functions are able to read and write data into the state of your contract. View functions can just read data, and pure functions can compute data but can neither read from state or write in it. We will make it clearer with examples in a bit. Next, in the syntax, we have returns with comma separated data types for returned values. Let's start with the scope. First, we have public. This exposes your function to internal as well as external calls and is usually more expensive than either of the counterparts. Next, we have private. This restricts your function to just this particular contract calls and can't be called in derived contracts. Next, external is used to expose the function to just the external calls and is cheaper than public for this use case. Finally, internal is similar to private, but it exposes the functions to derived contracts. You can read more about these in the link in the description. Now let's take a look at some examples. Let's start by taking a look at OpenZeppelin's ERC20 contract. You don't need to worry about the significance of ERC20 just yet. We will cover this in a future video. But for the time being, just know that the ERC20 implementation by OpenZeppelin has a mint function which allows user to mint a certain amount of that particular token into a given address. As you see here, this function is set to internal. This means that while we can call this in any derived contracts, we can't call it externally. This is useful in this case because we don't want anyone to go around minting tokens to their address, and we may also want certain checks, condition or extra logic before or around the minting process. For this, in our contract, we can create an external function that can call this internal function. If we wanted to call that function from inside our contract as well, we could have made it public. If we want a function that can't be accessed even in derived contracts, we would make it private. But since we wanted mint function in our derived contracts, we keep it internal. Now let's take one example for a view and pure function. Let's create a variable and create a simple function to set its value. Next, let's create a view function that would return this value. This is pretty simple, and if we just wanted to get the stored value, we could have simply made the variable public and it would have a public getter. But with view function, we can perform some action around it and then return the value. So if we want to return a value that's greater than 5, we can simply do the calculation and then return. Pure functions are used for simply computing data. We can add 2 values or perform some other calculation here and then get the result. Thing to note here is that all view and pure functions are gasless but still will face block timeout in case the processing takes too long. They are processed locally on the node, and node operator can decide timeout for processing these. If you call a view function or a pure function inside a simple function, it will still cost gas. While gasless nature of pure and view functions will make you feel that you can ignore the efficiency of your code, you should try to optimize the code to the point where you aren't just requesting bulk data or performing heavy computation, which may just result in RPC timeouts. That's it for this video, but there's more for you to watch. Check out this blockchain playlist or this video that YouTube recommends for you, and we'll see you next time.